In this video I will teach you how to balance basic chemical equations. Let's start with the basic method. First, count the number of atoms of each reactant. That is, the specific atoms on the left-hand side. Count the number of corresponding atoms of each product. Change the coefficients so that the equation balances. Namely, so that the left and right-hand sides are equal. Finally, remember how to count atoms. We take the coefficient and multiply it by the subscript. If there is no coefficient or subscript shown, that means it has the value of 1 and is not shown for simplicity. Recall a similar usage in algebra for variables. We will see examples of this process throughout the rest of this video. Methane and oxygen react to produce carbon dioxide and water. We are given the unbalanced equation representing this process. As our first step, we count the atoms on the left. Let's start with carbon. Let's see. We have one carbon atom on the left and one carbon atom on the right. Everything is okay there. Let's move on to hydrogen. There are 4 hydrogen atoms on the left and only 2 on the right. So let's add a coefficient of 2 to the water molecule to make 4 hydrogen atoms on both sides. Now what's left? Only oxygen. We have 2 oxygen atoms on the left, but 4 on the right. So let's add a coefficient of 2 to the oxygen on the left. There, now we have balanced our first equation. Moving on, we have phosphorus oxide combining with carbon to produce tetraphosphorus and carbon monoxide. If you do not know why we gave those molecules those specific names, forget it. Our first step should be to notice that there are 4 phosphorus atoms on the right and only 2 on the left. So we add a coefficient of 2 to the left molecule. Next we notice that our last operation also multiplied the amount of oxygen atoms by 2. We have 10 oxygen in the left and only 1 oxygen on the right. So we add a coefficient of 10 to the right molecule containing oxygen. Now notice that carbon on the left is also unbalanced. We fix this easily to give us our final, balanced equation. Now let's review our algorithm more closely now that we have done a couple problems. First, notice inequality in the number of atoms for a specific type of atom. When we say type of atom, we mean the kind of atom such as carbon or nitrogen or oxygen. Next, add or change the coefficient on the appropriate molecules so that the inequality no longer exists. Notice additional inequalities and mess around with the coefficients until the number of atoms on the left equal the number of corresponding atoms on the right. Check your answer by counting the atoms on the left and seeing if they equal the corresponding atoms on the right. Remember that if you have a multiple-choice problem on an exam for balancing, a trick is to plug in the given coefficient and seeing if the particular arrangement of coefficients will balance the atoms. The law of conservation of matter is what explains the logic behind all balanced chemical equations. We notice that there are 6 carbons on the left and only 1 carbon on the right. Add a 6 coefficient on the right. We notice that there are 6 hydrogens on the left and only 2 on the right. We add the appropriate coefficient to the right. For our next step, it gets tricky. We are to examine the oxygen atoms. There are 2 oxygens on the left and 15 oxygens on the right. Take a moment to pause the video and verify these counts. But oxygen on the left comes in 2 atoms each. Recall that we cannot change the subscripts, only the coefficients. I'll repeat that for emphasis: we cannot change the subscripts, only the coefficients. So how many O2 molecules will equal 15? Logic and practice will tell us 15 over 2. We could just leave the coefficients just like this, but it is not conventional. We can multiply everything by 2 to get the 2 out of the denominator. And we are left with the balanced equation in its conventional form. Let's take a look at one last reaction. Silver chloride plus difluorine will give us silver fluoride and dichlorine. Our instinct should be to notice that chlorine on the right has 2 atoms, and only 1 on the left. So we add a 2 coefficient at the left. Then we notice that there are 2 silver atoms on the left and only 1 on the right. Fixed. Finally, there are 4 fluorine atoms on the right and only 2 on the left. The balanced equation here fixes that.